Hey, you guys, depending on what day you're watching this, I'm pretty sure I'm supposed to graduate in a couple days, but with the schools being closed and the lockdowns, they postponed it, so I wanted to wear my NIU stuff anyways. Go Huskies. We're gonna keep going with our notes today, chapter 11.2. Uh, but keep in mind, Huskies, NIU, let's go. Chapter 11.2. Okay, you guys, so here's our 11.2 notes, arcs and central angles. So we're going to highlight, as you can see, I already started, but so a central angle is formed when two sides of an angle meet at the center of a circle. So here in this picture, we have this side and this side come together at the center of the circle and create a central angle. So this is an example of an arc. There are three types of arcs. A minor arc is part of the circle in the interior of the central angle with measure less than 180. A major arc is part of the circle in the exterior of the central angle. And semicircles are congruent arcs whose endpoints lie on a diameter of the circle. So these definitions are a little confusing, but they'll make more sense once we see them in action. So let's come down here and it'll help us a little more. Arcs are named by their endpoints. So we have point P, point G, point R. We have all these points on our circle. So in this first diagram, minor arc PG. So here we have our central angle is this spot on this picture, okay? Up here it says minor arc is part of the circle in the interior of the central angle. So this is the interior of the central angle, and that is going to be our minor arc here, okay? Major arcs, let me label central angle in all of these for you guys. There you go. Major arc is part of the circle in the exterior of the central angle. So if this is our interior of our central angle, the minor is this one. The major is the one around it. See that? And it's greater than 180, as where the minor arc is less than 180. And see how this one is labeled PRG? It tells us that we have to go all the way around the circle. Because if I just said major arc PG, it could be this one too. Or this one if the R wasn't there. But since it says PRG, we know it's this whole arc right here. Okay? And then semicircle is essentially a diameter of a circle here, and technically it could also be this one as well. All right? And those are equal to 180. All right. This diagram is going to be very helpful, I think. All right. So note that for angle A, 2 letters are used to name the minor arc, but 3 letters are used to name the major arc and semicircle. These letters for naming arcs help us trace the set of points in the arc. In this way, there is no confusion about which arc is being considered. Depending on the central angle, each type of arc is measured in the following way. So, the degree measure of a minor arc is the degree measure of its central angle. 2. The degree measure of a major arc is 360 minus the degree of its central angle. And lastly, 3. The degree measure of a semicircle is 180. Okay, remember semicircles look like diameter. It's a straight across line. All right, so let's look at this first example keeping in mind these things up here. Circle R, so that's this, KN is a diameter. Okay, that's straight across. It wants us to find the measure of arc, ON, angle of NRT, measure OTK, and the measure of NTK, which is this one. Okay, so the first thing we can know is that ON is going to have the same arc measure as the angle. So we can say that measure ON is 42. The next thing it wants us to find is NRT. So we know that the arc angle is 89, so we know that the inside angle is also going to be 89. Okay. It wants us to find the measure of OTK, so this big one. Okay. We can find this arc because we know that NK is diameter, which means it equals 180. So I can subtract 89 from 180 to find this measure. And I get 91. So that means this is 91. So to find OTK, I have to add 91 plus 89 plus 42. Or just 180 plus 42, which I might do that one the next time we have a problem like this. 91 plus 89 plus 42 equals 222. So I have measure OTK equals 222. And then lastly, it wants me to find NTK, which we know is a semicircle because we know that NK is a diameter. So we can say that measure NTK arc is 180. All right. And if we add, we can double check. If we add OTK plus the measure of this arc, which is 138, we should get 360. And we do. So we can check our answer. All right. I know it's a little tricky. There's lots of lines and things to look at, but once you find one measure, it helps with the next one, okay? All right, let's flip the page. All right. So in circle P, find the measure of arc AM. So that's this. Measure of angle APT. And then it wants us to find the major arc THM. Okay? So the first thing we can do is we know the arc is going to be the same as the central angle. So we know measure of arc AM is 46. we know that if the arc is 50, the angle is going to be 50. So measure of angle APT is going to be 50. And to find this, we can add these up and subtract from 360. So I have 96, 360 minus 96. And I get 264. So the major arc, or arc THM, is going to be 264. All right? Okay. Let's move down. In circle P above, oops, AM and AT are examples of adjacent arcs, meaning they share a side. Or in this one, share a point. And they both share point A. Okay? Adjacent arcs have exactly one point in common. For arc AM and arc AT, the common point is A. The measures of adjacent arcs can also be added, which is what we did in this top problem. So the sum of the measures of two adjacent arcs is the measure of the arc formed by the adjacent arcs. If Q is a point on PR point, then the measure of PQ and QR is equal to the measure of arc PQR. Okay. So in circle P, RT is a diameter. (180). Find the measure of RS, ST, STR, so that's going to be this huge one, and QS. I'm going to go this way. Okay. So we're going to start with finding QS. I can add 75, and I know if the central angle is 65, then that's 65. So for measure of arc QS, I'm going to add these two together. So 75 plus 65, I get 140. All right. So I found that one. Next, it wants me to find, oh, RS, already found that one. Measure of RS, arc RS, 65. Okay. Now it wants me to find ST, so this one right here. I can do 180 minus 65 because I know RT is a diameter or a semicircle. So 180 minus 65. 115. So ST 115. So if I know this is 115, and I need to find this big one, actually I can do something else. If I know the central angle is 65, so the arc is 65, I can subtract 65 from 360 to get my major arc. See that? So I can do 360 minus 65. I'm going to double check that. 360 minus 65. Oh no, I was right. 295. So I know that this major arc, STR, equals 295. So I have my STR, check. RS, 65, check. QS, 140, and STR is 295. Oh, and ST we found was 115. All right. Awesome. All right, let's move down to the bottom one, number 4. In circle P, find QT. So if we already know what 115, ST is 115, RQ is 75, and we know what this huge one is, we can solve for this one. So let's add 115 and 75 together. So 115 plus 75 gets me 190. If this whole thing is 295, I'll subtract 190 from 295 to find this arc that we're missing. So it's 105. So measurement of QT, 105, which is this one right here. Perfect. All right, down this one. Circle P, find STQ. We know what QT is now, we know it's 105, and we already know what ST is, it's 115, so we just have to add them up. All right, and we get 220. All right, one more example. Sorry, these are long notes. These take a little bit, and they're a little tricky. So, all right, circle M, WS are diameters. RT is a diameter, meaning we know that their arcs are 180. Okay, so measurement of angle WMT is 125. And RK is 14. Find RS. So RS is this one right here. Okay, so I'm just going to start filling in spots. If I know RT is 180, I can subtract 125 from 180 to find this one. So 180 minus 125 equals 55. Same thing with this. If WS is a diameter, it equals 180. 180 minus 125 is 55. So now I have that, okay? To find RS, this long one, I can add all of these up and subtract from 360. So I'll do 125 plus 55 plus 55, and I will find my answer and subtract from 360. 125 plus 55 equals 235. So 360 minus 235 gets me 125. So this RS, 125. So now it wants me to find just KS, this one. So if I already know RS, and I also know RK, which is part of RS, is 14, I can do RS minus RK to find this opening. So 125 minus 14. I know that KS is 111. All right. And then lastly, ST, which we already found because we used our central angle and our diameters to figure it out. We know that arc ST is 55. Okay. This one's pretty tricky, guys, and it was a really long note session, so I apologize for that. But try the homework. Really try to go on the Zoom tomorrow or whatever day is next, and we can go over it and really work on the problems. I know this is a little tough, so don't freak out. Try the homework. We'll give you points if you complete it and give it a good effort, but we can go over Zoom for sure. See you guys later. Bye.